Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This test is especially for you. You people are asking again and again about the fluid dynamics test. So here is the test of fluid dynamics. Please keep one thing in your mind, that these are the difficult ones. Other problems will be easier than these. Okay. So let's start. Number one. Two light balls are suspended as shown in the figure. We have a figure. You can see that there are two balls. One is this one, other is this one. They are suspending with a rigid support, and these are light balls, means their masses are very light. When a stream of air passes through the space between them, if air passes through between them, like say these, air is passing through them, okay, then what happened? The distance between them will be increased, decreased, remains the same, or may increase or decrease depending on the speed of air. What's the physics behind it? Okay, physics behind it is this, that when air passes through between these two balls, it reduces the pressure. Air pressure will be reduced between the balls as compared to the external atmospheric pressure. Here we have high pressure and here we have low pressure. As a result, what will happen? A net force is created which pushes the balls towards each other. So the distance between them will be decreased. Okay, move to the next one. The rate of leak from a hole in a tank is more if situated near its top. Second option is more at midway between top and bottom. Third is more if situated near the bottom. And the last one is independent of its height from the bottom. So this is totally wrong. It does depend upon height. Let's this be a tank. If leakage is from here or from here, two options let's suppose, then the water will come out less from this leakage, the top one, if the holes are of same size, and due to the pressure more liquid will come out from the bottom one. So the result is more if situated near the bottom. The third one, raindrops are spherical because of what? We know that the raindrops are of nearly spherical type. Okay, so why they took this shape? The reason behind this is the surface tension, which is the property of liquid, especially here water, due to which the hydrogen molecules stick together and the size of the drop is reduced, and it took the type and it took the shape of a spherical. So this is due to the surface tension. A cylinder is filled with a non-viscous liquid of density ρ at a height h0, and a hole is made at a height h1 from the bottom of the cylinder. The velocity of the liquid issuing out of the hole is. So let it be the cylinder, this be that cylinder. Now what they are saying, again repeat, a cylinder is filled with a non-viscous liquid, means no role of viscosity. Density of the liquid is ρ, symbol of density, to a height h0. This liquid is filled, let's suppose up to this point. This is h0, okay, and a hole is made at a height h1. Let's suppose the hole be here, h1, from the bottom of the cylinder. This is the height from the bottom of the cylinder, this h1, and this h0 is the height of the liquid in the cylinder. The velocity of the liquid issuing out of the hole. The liquid will come out from this hole. They are asking what is the velocity of the liquid which is coming out from this hole. Okay, we have to use Bernoulli's equation over here, and Bernoulli's equation states that P1 plus half rho V1 square plus rho GH equals to P2 plus half rho V2 square plus rho GH. As the cylinder is open, so both pressures are equal, P1 and P2. So P1 and P2 are equal, therefore we can cancel them out. Now we are left with, this is half, this is rho. The first speed of the water over here. Here we have V1, this is V2, At the surface, absolutely about no movement over there. So V1 will be negligible as compared to V2, and we can write, instead of V1 we will write 0 plus, over here we will left with rho G. This H1 is H0, the upper point, and here we have half rho, here we have V2, this is V2 square plus rho G. This point is, instead of H2, this point is H1, okay, because our top point is H0, which is H1, bottom point is H1, which was H2 in the equation. So we are here with this equation. This factor becomes 0 as it multiplies with 0. We're left with rho G H0 equals to, I can take rho as common, then we'll have half V2 square plus G H1. So rho cancels with rho, okay, we'll having G H0, this will come to the other side, this become minus G H1, this is half V2 square, this 2 will move to the other side, it will come over here, I will take G as common, so I will be having 2G H0 minus H1 equals to V2 square. So V2 will be equals to, take the under root, 2G H0 minus H1. So the correct option is this one, A. Okay, let's move to the next one. Two boats moving parallel in a river. Then what happened? Number 1, get apart due to increase in pressure in between them. B, are pulled towards each other due to less pressure in between them. C, remains always parallel as there is no change in pressure. And D, none of these. So this will be answered as per the Bernoulli's principle, which states that as the speed of a fluid like water increases, its pressure decreases. So when two boats move parallel in a water like this in the same direction, the speed of the water between them will be increased, and so as the pressure will be decreased. So we can see that the boats will move towards each other. Why? Because the inner pressure will be reduced and outer pressure will be greater. Okay, so the boats will be pulled towards each other due to less pressure in between them. The option B is the correct option. The next is, as compared to external atmospheric pressure, the pressure of blood inside the vessels is, options are greater, lesser, 0, no comparison. What's your opinion? Yes, the pressure is greater. How? Because if you found a cut at your finger, let's suppose this will be cutted over here, then what will happen? The blood will come out. Means what? The liquid always flows from the high pressure to the low pressure area. This proves that the inner pressure is greater, the outer pressure is less. Okay, so the option is greater. When a fog droplet moves vertically downward, it is subjected to, okay, fog droplet when moves down towards the earth, then what happened? Which forces acts on it? A drag force only. Drag force is the force which acts vertically upwards. This is the drag force. Yes, this will act on the fog droplet because it acts on each and every object which falls from the atmosphere towards the ground. Force of gravity only. We know that the bodies moves towards the earth due to the force of gravity. Means what? This is G. So the C is the correct option. Both drag force and gravity. The next one is, high concentration of red blood cells increases the viscosity of blood from 2 to 3 times that of water, 3 to 4 times that of water, 3 to 5 times that of water, 4 to 5 times that of water. In some books, according to some data, this is 3 to 4 times. Some other will inform you that this is 4 to 5 times. So when you check completely, you can find it that it starts from 3 and it ended at 5. So the correct option is 3 to 5 times. Ball pen functions on the principle of ball pen. This is a ball pen. How this is moving? Like this. Okay. It functions at which property of physics? Boyle's law? Not at all. Surface tension? Maybe. Gravitational force? Maybe. Viscosity. So when you differentiate between ball pen and fountain pen, ink pen, you can find that the ink pen works at the principle of surface tension and gravity. But in case of the tip of a ball pen, this continuously rolls inside and then it comes to outside. So it brings what? It brings ink outward due to viscosity. Okay. So the correct option is viscosity. We have drawn what? During this time we have drawn a tree, which is necessary nowadays. So viscosity is the correct answer. An incompressible fluid flows steadily through a cylindrical pipe which has a radius 2r at a point A. Let this be the pipe. This is point A and the radius at point A is 2r. The radius at point B is r. Farther along the flow direction, the liquid is flowing from point A towards point B in this direction. If the velocity at point A is v, then what will be the velocity at point B? Velocity at point B. This is v1, this is v2. Okay. So according to continuity equation, we have a1 v1 equals to a2 v2. A is area of cross section, v is velocity at point A, and a2 is area of cross section and v2 is the velocity at point B. What we have to do, we have to find out the difference between the area of cross section. The formula is pi r square. So at a1 we have 2r, so this becomes a1 equals to pi 2r whole square. So a1 is equals to 4 pi r square. a2 is pi r square, and as the radius at point B is r, this will remain as it is, pi r square. Here it was shifted into 2r because here the radius was 2r. So now put these values in the equation and get the result. Instead of a1, I can write this 4 pi r square, velocity is v1, and a2 is pi r square v2. This pi r square cancels with pi r square. Let v1 equals to v. So v2 is equals to how much? 4v. So the correct option is A. Thank you. Inshallah we'll meet in the next test very soon. Take care. Allah Hafiz.